So x equals 25. Number 10, my whole goal is to get the x by itself. So if you think about trying to get the x by itself, sometimes I think about doing PEMDAS backwards. Well, that's whenever you're simplifying, but if you're solving, like if you're going backwards, PEMDAS backwards. If you don't want to think about that, you don't have to. No worries. But on number 10, logically, maybe not even thinking about PEMDAS, what would your first inclination be to do first? See, no. You want to move the 8 first. So add or subtract. That's why PEMDAS backwards. I want to add or subtract first. So I'm going to subtract the 8. And I have 1/2 square root of x equals -3. Now I multiply the 2.
So you're trying to get like the easiest form possible?
Exactly. So when I multiply the 2, I get square root of x equals what? -6. And so then x equals, in parentheses squared.
Oh, it's in parentheses.
Yes. So x equals 36.
I got 34.
What?
I didn't do that.
So add or subtract first, then multiply, divide,
You have to.
then square. So what did you do? Multiply everything by 2?
I got rid of the square root first and then square root.
That's your very, very, very last step, always. And if you don't do it for your last step, then you'll get a different answer. Because if you squared like if I squared this right now, I would have 2 terms, which would mean I need to FOIL it out. You can't just apply the squared. That's killing a puppy. So that's probably why that happened. Okay, try number 11.
Yay.
Perfect.
If you got that wrong.
Hold on.
Hold up.
Okay, number 12, I've got square root equals square root. And these are actually the easiest kind of problems.
For sure.
Because all you got to do is square them both. And essentially, the square roots just go away. They just drop. So I get 2x minus 1 equals 5x. And from there, -3x equals 1, x equals -1/3. Something that we have not been doing yet is checking to make sure that these answers are non-extraneous, which with these kind of problems, like the easier ones, 9 times out of 10, they're not extraneous. Like if I just mentally checked number 9, that would work. If I plug in 36 here, it would be 1/2 of times 6, so 3 plus 8 equals 5. Does that work? So when I plug this in, 1/2 times the square root of 36, which is 6. Oh, I put third. Plus 8 equals 5. 3 plus 8 is equal to 5. Does that work? No. So I would say no solution. So with these kind of problems, when you check them, if it doesn't plug in and work, then you say no solution, but you have to show your work of how you got it.
Are they all going to be extraneous on the big quiz?
There are going to be probably some that are extraneous. Okay, if I try plugging in number 11, I get square root of 12 minus 8 plus 1 equals 3. So square root of 4 plus 1 equals 3. 2 plus 1 equals 3. That one works. So all I'm doing is I'm going back and plugging in my answer.
What do you mean that works? Wait, can you do that again?
So I got this 12 by taking 4 times 3.
Yes.
And then minus 8. So that would be square root of 4, which is 2.
Yes.
And 2 plus 1 equals 3.
Oh.
Matt Ryan.
I got it.
Okay, what about number 12? If I plug in negative 1/3, I get the square root of negative 2/3 minus 1 equals the square root of negative 5/3. Are those the same?
But, no. I don't think so.
Well, what could I change this 1 to be, like minus 1, if it had a common denominator? Instead of writing 1, it could be what over 3 would represent 1?
X.
No,
over 3.
3 over 3. Now is that the same?
Yeah.
Yes.
Wait, that's the same as 1 over 3?
Negative 5 over 3 is equal to negative 5 over 3. So instead of 1, I just made this 3 over 3.
So how does that equal negative 5 over 3?
Negative 2 minus 3. I just combined the numerators. All right, so number 10 was the only extraneous one there. Number 13, I've got a square root on both sides, but I also have this 4 attached to it. So when I square both sides like this, what happens is the square roots get dropped, but I also have to square the 4 as well. So it would be like 16x equals 4x plus 2. So 12x equals 2, x equals 6.
I need to do physical
It would be 1
thing
over 6,
to
right?
wake me
Because you have to divide by 12.
It would be 1 over 6.
What?
Divide by 12.
Divide by 12.
I knew it. There's not ones.
That's tonight.
Okay, with number 14, I'm going to do the same thing. The square roots will get dropped, but then I also have to square the first terms as well. So what happens when I square 1/2? No, like what's 1/2 times 1/2?
1/4.
Yes.
1/4.
So 1/4 x equals what? 9 parenthesis 2x minus 1. So go ahead and finish that problem out. We feel okay about this one?
I got negative 6.
Yeah, I think so.
Just look at it for a second.
Because I got.
Just think about it.
Well, wait.
It's.
Yes.
Okay.
So you could just separate the 1 over 4 from x just by multiplying.
Mm-hmm.
Easy.
I didn't do that.
Did you get a common denominator? Because that works too. And then you would have 1/4 x minus 72 over 4x
That's what I.
equals negative 9. So negative 71 over 4
Well, I didn't.
x equals negative 9. And then multiply by 4. So negative 71 x equals negative 36. Divide by negative 71. So then they should both be negative. And when you divide a negative by a negative, it becomes a positive.
Wait.
So I'll come.
Why is 71 and 4 negative?
Because they both are negative.
They shouldn't both be. The 1/4 is already positive.
I know, but like. The negative 71 and the 4.
No, only the negative, like Only one of them is, if the whole thing is negative, only one thing is negative, not both of them.
So then had to. Okay.
Okay, let's look at 15. So what would you say the difference is between something like 13 and 14 versus 15?
15 has a plus 1.
It has a plus 1 at the end, and there's really nowhere for it to go. Like, I mean, I could move it to the other side if I wanted, but that's really not helping anything. So these are the ones that I would say are the most challenging. So you won't have too many of these, but I'm going to show you basically when you add and subtract and you still have two radicals on the side, but you've got something on the outside like a plus 1 or a minus something. You're still going to need to square both sides, but we're going to have to FOIL a little bit, okay? So when I square the left side, what does that become? X minus 1. Yeah, super easy. On the right side, when I square this, I would kill a puppy if I said x plus 2 plus 1 squared. That would be killing a puppy. I need to actually FOIL this out. So, FOIL. Write that out and underline it, bold it, capitalize it. Do not kill a puppy on this. So, I'm just going to rewrite this twice, and I'm going to put x plus 2 plus 1. And here is what ends up happening every time. Is this going to show up? There we go. Okay. So when I multiply the first term, so this one and this one first, all that ends up happening is the square roots get canceled out. So for my first term, it's just x plus 2. When I multiply the outer, so 1 times square root of x plus 2, what is that? Just square root of x plus 2. When I multiply the inner, square root of x plus 2. And when I multiply the last, 1 times 1 is 1. From there, yeah, I can combine my like terms. So I've got x minus 1, I'm just going to leave that there for a minute, equals x plus 3 plus, I can combine these two to just be 2 square root of x plus 2, because there's 2 of them.
Could you do 2x plus 4?
No. So if there's 2 of them, then they can be 2. Then I move the x over, and I move the 3 over. So subtract x and subtract 3.
Does the x cancel out?
It does. So when I subtract x on this side, that cancels. And when I subtract 3, I end up with what on the left side of the equal sign? So negative 4 equals 2 square root of x plus 2. Now can we solve this problem?
Yeah.
So what do I do, Jackson? What do I do next?
You do the square root thing. Where you put the exponent.
Put the exponent?
Yeah.
Okay, I could do that. Could I also divide by 2 first?
Yeah.
Okay, let's do that. That seems easier to me. So then I get negative 2 equals the square root of x plus 2. Now I do what? Exponent thing. So 4 equals x plus 2. X equals what?
2.
Good. Now with these kind of questions, like this one, since you got a really nice, neat answer, you could check it. On number 13 and 14, that would be a question that you would have to check with your calculator, okay? I'm not going to ever ask you to do something like that. So if you get a really messy answer, it would be on a calculator question. I could check number 15, though, by plugging it back in. So let's plug it back in and just check and see really quickly. So on the left-hand side, square root of 2 minus 1 is just square root of 1 equals the square root of 4 plus 1. So it's saying 1 equals 3. Is that true?
No.
No. So I did all of that work for there to be no solution.
Why is 1 equal 3?
If you plug in 2 for x on both sides, you would get 1 on the left side and then 3
On the right side?
on the right side.
You get 4.
You get the square root of 4 plus 1.
How's that 3? Oh.
2 plus 1.
Okay.
So I'm just going to put an x through that. No solution. If on a test or something you just guessed and put no solution and that happened to be the right answer, I still wouldn't give you credit for that because I would still need to see all of the work. Okay, try number 16 with your table. The last one of this kind. But whenever you FOIL something like this, there's kind of a trick that it's going to happen every single time. So if I want you guys to put your pencils down and just watch this. If I am squaring this, it's like I'm writing it twice. What happens every time is the first term gets squared. So I'm going to put an x here. The last number is the last term gets squared. So I'm going to put a plus 16 on the end. So the first and the last ones are really easy because you just take the first term and the last term and square it. The middle term is always taking these two terms, multiplying them together. So if I multiplied square root of x times negative 4, what would I get? Negative 4 square root of x. And then doubling it. So if I double that, I get minus 8 square root x. Because it's going to happen twice every single time. So if you square the first, square the last, double them multiplied by each other, it's going to work every single time. And then something like this, you could check with your calculator to see, just plugging it in your calculator and seeing if it's an extraneous solution or not. Which I don't know if it is or not.